General Chemistry. This is our Lewis dot structure tutorial part 2, where we deal with something more complex. We deal with double and triple bonds. Turns out that when we talked about covalent bonds, we know that each atom has a high electronegativity, and they're both pulling on electrons from each other, so they end up sharing. Each contributes electrons. It makes a hybrid orbital that the electrons surround both atoms, pulling them together. That's when they share one pair of electrons. But it is possible for atoms to share 2 or 3 pairs of electrons to make double bonds or triple bonds, where they're actually sharing more than 2 electrons at a time. So what is that? How does that work? Well, we're going to do some examples of that. We start the exact same way. We draw the dot diagram for each atom. And O2, a diatomic molecule, oxygen, is an example of this. So we have these 2 different oxygens here. We find the bonds between the unpaired electrons so all atoms are connected. So what does that look like? We'll do that again here. Well, these 2 can bond, right? But we still have unpaired electrons. This guy can bond to somebody and this guy can bond to somebody. So what they end up doing is they end up binding to each other. So how many connections do we have between this oxygen? These oxygens have 2 pairs of shared electrons now. So what does that look like in our dot diagram? We have to change the way our dot diagram looks like. We have 1, 2, 3, 4 unshared electrons on this oxygen, and 1, 2, 3, 4 unshared electrons on this one. But then we have 1 pair that is made from 1 of each, and a second pair that is made from 1 of each that they each share. So this oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons, and this oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons. When we switch over to our molecular models, instead of using 1 line to represent a shared electron pair, we have 2 lines because they're sharing 2 pairs of electrons. This is a double bond between these oxygen atoms to give us a diatomic oxygen molecule. We can also make triple bonds. One example of that is nitrogen, another diatomic molecule. We have our nitrogen. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They each have 3 unpaired electrons. Well, the same situation occurs. I kind of jumped the gun a little bit there. But this one will pair with that one. This one will share. This one can be shared. So how many connections do we have between them? We have 3 connections between them. So what does that look like? That looks like this. We have 2 unpaired electrons from each of them. 2 here, 2 here, 2 here, 2 here. But then we have 3 pairs of shared electrons, and that's these 3. 1 from each atom is shared, and we show a line for each shared pair, and that gives us a triple bond. So that's that. When you start adding other atoms in the mix, you can get molecules that have single, double, and triple bonds. You can get some pretty complicated molecules, but these are the fundamentals for multiple bonded covalent molecules using Lewis dot structures. I hope this helps. Struggle well.